right top, right? So this was a question which was asked in GATE 2005, right? So let us solve this question in a nutshell. So I told you that the transpose won't change the order. Transpose won't change the order, right? So if I say the order of, we are considered only by the order. So what is the order of X transpose? Order of X transpose will be 3 cross 4. And what will be the order of Y? It is already given 4 cross 3. So what will be the order of X transpose into Y? X transpose into Y. This is not X, but this is multiplication. Okay, so let us keep it X transpose into Y. So this will be nothing but, this is row column, right? So this will become ultimately 3 cross 3, isn't it? So can you tell me what will be the order of X transpose into Y inverse? I said inverse will have the same order. So this is 3 cross 3, right? Now if I talk about what is the order of P, P is given as 2 cross 3. What is the order of P transpose? It will be 3 cross 2. Very good, right? And P into X transpose Y inverse and into P transpose. This is what is the question given to us. So what I will say, this will become 2 cross 3 into 3 cross 3 into 3 cross 2, isn't it? This is P, 2 cross 3. This is X transpose Y inverse. This is 3 cross 3, right? And P transpose, this is 3 cross 2. So we have discussed 3 cross 2, right? So ultimately this will be cancelled out, this will be cancelled out. So ultimately the order will be how much? 2 cross 2. And the question was not this. This question was P into X transpose Y inverse P transpose and the whole transpose. So will the transpose change the order? No, it won't. So still your order will be 2 cross 2. So you can select the option number 2. You can, sorry, option number A. Option number A will be your answer. Got it? So this is a simple thumb rule which we can easily understand and follow. Right? Clear all the doubts? Let us move on to the next heading, that is trace of a matrix. Trace of a matrix. Now what is trace of a matrix? It's a very simple thing. Trace is nothing but, in a square matrix of order n, the sum of elements of the diagonal element is called as a trace. What I said was, in a square matrix, let's say, I'll give you an example. Let's say there is a square matrix 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is a square matrix. Now I said the sum of all the diagonal elements. So what are the principal diagonal elements? Principal diagonal elements are how much? They are 1 plus 5. These are the principal diagonal elements. 1, 5, and 9. So if I add all of them, this comes out to be 15. So I can say this is the trace of the matrix A. It's called as the trace of matrix A. The important thing is, what are the properties? Very simple properties. If I say trace of, let's say, lambda into A, where lambda is a scalar quantity, then it's very simply lambda can be taken out into trace of A. Okay, right? So that is the second part. Let us talk about second property. Trace of A plus B. Trace of A plus B. It can be, yes, very correct. It can be easily written as trace of A plus trace of B, right? And property number C, you can say, if it is that trace of A into B. A into B. This is not X. Let us not confuse this with X. This is A into B, right? So this will be equal to how much? Trace of B cross A. Trace will be same. See, I'm not saying A into B is equal to B into B. We have denied this fact earlier, right? Commutative property is not possible in multiplication, but we are saying trace will be equal. You can always check this out, right? Okay. Now we have discussed about transpose, but we have not discussed about the properties of transpose. So let us also discuss those properties of transpose, right? Because these small properties will be based in the questions, right? First property, very simple. If I say, let's say I say A transpose, this can also be represented A dash. Some books you will find that it is A dash of dash, right? What will be this? First, here you have converted your rows to columns, and again you are converting columns to rows, right? So the element is not changing, only the order was getting shifted. So again it will become what? A only, right? Second property says, if I say A plus B transpose, so this is very simply A transpose plus B transpose, right? Or if I multiply a matrix by a scalar K, let's say, so it is K A transpose will be equal to K times A transpose, and K is a scalar, right? So let's say something like another property. If I say A into B transpose, now this is something which you need to be remember. That is B transpose into A transpose. So practically you will find this, and let's say this is the E1, and this is something, if I ask you A into B into C transpose, this is how much? This will be C transpose into B transpose into A transpose. This is important. Okay. In some of the papers, you will find this, the fifth property which I have written as a direct result. In a paper it was asked to answer which option will say this particular thing. So you should be remember with all those things. Right? Next heading is conjugate of a matrix. Conjugate of a matrix. Conjugate of a matrix is very simple. For example, if I say a conjugate word is connected to which topic? Conjugate we are talking when we are talking about, yes, very good, complex numbers, right? So if I say there have to be a complex number, let's say there 3 plus 4 iota, and this is 6 minus 3 iota, and let's say this is 8i, right? This is a matrix which is given to us, right? So if I wish to let's say find out what will be the conjugate of this, so each element will become the conjugate, right? That means normally conjugate is represented by bar on A, so A conjugate can be represented by real number will have the conjugate same only, because real part is not having any difference in conjugate, right? But this, let's say 3 plus 4 iota will have a conjugate. What will be conjugate? 3 minus 4 iota. Similarly, this will become 6 plus 3 iota, and similarly this will become minus 8 iota. So this is the conjugate of the matrix, right? Very simply you can say, right? Okay, so let us also discuss the properties here, because we have discussed the properties of transpose, we have discussed the properties of trace. Let us also discuss the properties of conjugate. So what does the property of conjugate says? That first property is very simple. If we talk of the first property, that if I take A conjugates again conjugate, what it should become? Yes, very correct. It should become A only, right? For example, if I say one element Aij element of A is given by 3 plus 4 iota. So if I take the conjugate of Aij, it will become 3 minus 4 iota. And if I further say that conjugate of Aij is conjugate, so it will further becomes 3 plus 4 iota, which is actually equal to Aij element only, right? So we have the same thing which is coming out, right? You can prove it very easily. Second property says, if I say A plus B conjugate, it's very simple. It's nothing but A conjugate plus B conjugate. Right? Don't confuse. Mostly electronics guys and computer guys may confuse this with that Boolean algebra thing. This is not the theorem of Boolean algebra, right? This is very simple conjugate thing, right? Okay. So here again, if I say multiplied by scalar, same questions which comes to transpose. So you can say it is K bar and A bar. Right? Why I kept k bar? Because k can be a scalar, or you can say k can be a complex number also. It can be 3 iota, it can be 4 iota, something like this. Right? Similarly, The next was multiplication. If A into B multiplies what I'm doing, so this is nothing but A conjugate into B conjugate, right? Okay. Now, if I find the conjugate of A and if it comes out to be A, when will this happen? This will happen if I have a matrix A something like 2, 3, 4, 5. You know, if I find the A conjugate of this, it will be what? 2, 3, 4, 5 only. Because there is no imaginary part. So can I say that this will happen if A is a real matrix? A is a real matrix, right? Similarly, if I say that A conjugate is equal to minus A conjugate is equal to minus A, right? Let's say A is now this times 3 iota, 4 iota, iota, minus 6 iota. Example I will take. So what will be A conjugate here? A conjugate will be minus 3 iota, minus 4 iota, and 6 iota. Can I write this as minus of A? Yes, if I take minus common, it will become A only. So this will happen when? If A is purely imaginary. A is purely imaginary. Yes, very correct. So if these things are happening, see, these are small conclusions which you will have to draw every now and then. Because in a gate paper, you will not get straightforward questions. You have to take conclusions, right? Okay. Next thing we'll discuss, that is transposed conjugate. Now, what is transposed conjugate? As the name is suggested, it will involve conjugate as well as transpose. So this is nothing but it is denoted by A theta, or you can say A conjugates transpose. Right? For example, if I say there is a matrix A, which is, let's say, 3 plus 2 iota, 4 minus iota, 6, and let's say 1 minus iota. Right? So this is a matrix A. So we wish to find, let's say, example only, we will take this, and you wish to find A theta. What is A theta? Transpose conjugate of this matrix, right? So first, what we'll say, we'll find, first of all, let us take A conjugate. So A conjugate will become how much? 3 minus 2 iota, 4 plus iota, 6 will it become minus 6? No, this will become 6 only, because real part will remain the real part, and then we will say 1 plus iota, right? But this is what A conjugate. We wanted what? A conjugates transpose, and that is what we were defining as A theta, right? So let us take the transpose of this. This element will become 3 minus 2 iota. Here the row will convert to column, that is 4 plus iota. This will be 6, and this will be 1 plus iota. So there is a very simple thing which we have concluded, that A theta, or the transpose conjugate, we have found. Clear? So this is a very simple thing. Right? Now let us also discuss about the properties of a transpose. Properties of transpose conjugates, right? So very simple, same kind of property. If you say transpose conjugate will again give you A. If I say A plus B times conjugate, transpose conjugate will become A transpose conjugate plus B transpose. Most of the properties remains the same. If you multiply it with a scalar and then you find out the transpose conjugate, it will be nothing but K bar into A transpose, where K can be a complex number. K can be a complex number, in fact. And similarly, if you say the multiplication of two matrix complex transpose or transpose conjugate will be transpose conjugate of B into transpose conjugate of A. This is an important one. It is similar to what we did in the transpose thing. If you remember, properties of transpose, right? Clear? Now let us take on the next thing, that is for a real matrix. Classification of classification of real matrix or real matrices. First of all, we'll talk about symmetric matrix. Symmetric matrix. What is symmetric matrix? If for a matrix its A transpose is equals to A. If for a matrix A transpose is equals to A, right? For example, if I say let's take a matrix something like A, H, G, H, B, F, G, F, C. And let us find out its A transpose. So A transpose, what I said was that row will get converted to column. Second row will get converted to second column. And the third row will get converted to third column. Can you see that A is equals to A transpose in this matrix? Yes, yes, absolutely. All the elements, when they will be equal, when all the elements are equal. So I can see that all the elements are equal. So that is how I can say that A is equal to A transpose. Hence the above matrix is what? Symmetric. Very good. The above matrix is symmetric. Correct? Second is something called as skew symmetric matrix. Second is skew symmetric matrix. Right? Now for skew symmetric, if you say A transpose is equals to minus A transpose is equals to, if I say if A transpose is equals to minus A. For example, let's say another simple example. Let us take. Let us say there is a matrix A of the nature something like this. I've taken some special type of a matrix. Right? Now, can you tell me that what will be A transpose? What will be A transpose for this? Very simply, you can find that rows will be converted to columns and the columns will be converted to rows. So if I find A transpose for this, A transpose will be very simply, this element won't change, right? The rows will become column and column is going to become the row, right? So this is how it will look like, isn't it? Now if I take minus sign common of A transpose, so this will become what? Minus of A transpose is nothing but 0HG minus H0F minus G minus F and 0. Isn't it equal to A? Yes. Is it equal to A? Yes. So we can always say that if minus of A transpose is equal to A, or A is equals to, or you can say A is equals to minus A transpose, then this is a condition for skew symmetric matrix. Skew symmetric matrix. Now, what is the importance of this? See, in industry exposure, you will find out the importance of this. When you go to industry, you have to define a matrix. See, matrix is nothing but system parameters, right? So these are elements of the system parameters we fix up in the matrix, right? So as an engineer, we should understand why these things are important for us. So when you are finding out, the system parameters, so on the basis of the symmetry or skew symmetry, we come to certain conclusions. So when you go to the industries, you will understand things in depth.